For our project, we decided to look at the effects of mid-focus exercise on reading ability in normal versus comorbid respiratory physiologies. The background of our experiment stemmed on looking at two different organs, the lungs and eyes. And obviously the lungs will supply oxygen to the eyes in order to see. And so the reason why we wanted to look at these two organs is because previous studies studying obstructive pulmonary disease such as pulmonary fibrosis have shown that a restriction in the oxygen, the restriction that the disease plays on the lungs, limits the amount of oxygen that's able to go to the eyes and therefore causes blurry vision, cataracts, and even dry eye.
The specific aim of this experiment is to test how lung capacity affects the reading ability of subjects with lung disease and non-affected lungs. To test the reading ability, the sacchardic eye movements, total duration of reading passages, the respiratory rate of the subjects with affected lungs and non-affected lungs will be recorded and then compared when reading an easy reading and a hard reading silently. This will be recorded 2 times before and after the moderate exercise.
In terms of methods, supplies we needed were the EOG electrodes, and then for the pulmonary function section of the experiment, we used the airflow transducer. We had 4 total subjects, 2 having pulmonary morbidities and 2 having normal pulmonary function. The procedure that we followed is to first have calibration of the eyes, having the subject look in the center, to the right center again, to the left center, going 2 times for that, and then to kind of get the calibration for the pulmonary function, having the subject breathe normally for 60 seconds. Following this, we had the subject kind of read a easy and hard passage while breathing normally, and after that, they exercised for 5 minutes without all the equipment on. Such kind of things that some people did was running in place, sit-ups, jumping jacks, etc. And after this, we had the subject then read another easy and hard passage. It should be noted that both the easy and hard passages before and after exercise were different. However, they did have the same words per line and number of lines.
Our hypothesis for this experiment was that we expected the reading speed to decrease during the post-exercise period for subjects with restrictive respiratory morbidities as breathing becomes more strenuous and demand to the lungs increases. However, our results for this experiment showed that while we did see an increased respiratory rate after exercise for all subjects, most of the post-exercise reading rates were actually higher than the pre-exercise reading rates for most of our subjects under most of our conditions. There were 2 exceptions. We also saw that there was no significant difference between the performance between normal physiologies and people with respiratory conditions, and reading speed increased the most in one subject by a decrease of 8.5 seconds for a 9-word passage.
The result shows that the total duration of reading difficult passage are longer compared to reading a more easy passage. This is because the eyes must move slower to spend more time concentrating on each word when the brain processes the more challenging words and identify them correctly. Thus, the total duration of a more challenging passage are longer due to the slower eye movements. More interestingly, the most of the total durations of post-exercise were shorter than that of pre-exercise. This is mainly because the increase in blood flow and oxygen to the brain allows the subjects to better focus on reading and thus read faster than pre-exercise situation.
Possible applications from our results could be academic institutions implementing an exercise before exam approach, which would theoretically increase exam scores. Likewise, a device could be made that would be implemented in schools for everyone to use, the increased respiratory rate, and again, theoretically increase exam scores. In conclusion, our hypothesis that reading speed will decrease post-exercise for all subjects was incorrect, as our results showed that as respiratory rate increased, reading speed increased as well.